This is video number 4 for sections 5.1 and 5.2, inverse functions and equations. So this time I've given you the equation of a function, and let's play around with that a little bit as it relates to these inverse function ideas. Of course, the first example here, it has nothing to do with inverse functions. We've done this many, many times. We're just being asked to go to the original function and replace all of the x's with 4 and work out the math. Just some simple arithmetic, and I can carry this out. Maybe I'll think of this as 4 over 1. I've got some canceling here, and I think if I'm doing this correctly, this turns out to be 6 plus 6, which is 12. F of 4 is equal to 12. In other words, when I stick 4 in to the function, I get 12 out. Second example says find F inverse of negative 6. Well, this is going to be trickier because I don't have the equation of the inverse function. If I did, I could just stick negative 6 into it. All I have is the equation of this original function. So again, I'm going to have to think creatively here. I know that this is an input in the inverse function. In other words, this is an x to the inverse function. But that means in the original function, this negative 6 would be treated as a y. If it's an input here, it was an output back there. So the way that I would have to determine this answer using the original function is I would have to replace the negative 6 where the y normally goes. In other words, here on the left, right, in place of the f of x. This is not going to be quite as easy as the last one. I'm going to have to do some algebra here to get x by itself. Let's see, I guess I could clear the fractions. I could multiply everybody through by 2, and that gives me negative 12. Let's see, on this guy the 2's would cancel, and then I have a positive 12. And then the rest of the steps are pretty straightforward. Subtract this 12 over the other side, and divide both sides by 3, and I get x equals negative 8. In the original function, when the output is negative 6, we just figured out that the input is negative 8. Well, that's all going to be reversed for the inverse function. For the inverse function, when the input is negative 6, the output will be negative 8, and that would be my final answer. Now, of course, that last example there would be much easier if I just had an equation of the inverse function. And that's the main thing that I want to show you here. How do you actually take an equation and find its inverse? Well, there's a little process that you go through each time. It's the same thing each time. I've given you the list of steps in this box. Let me demo for you on our example function. So I've copied the function down. Let's run through the steps. Step 1, the f of x notation, the function notation, kind of gets in the way in this process. So we're going to go ahead and replace that with a y. Let's do that. And then the primary step is really step 2. And it might sound kind of funny, but remember, an inverse function has all the inputs and outputs switched places. The x's become y's and the y's become x's. And so that's literally what you do in the equation. You switch the x's and y's. Whatever used to say y, you write x. Whatever used to say x, you write y. This red equation, this is the inverse function right here. It's just that it's not in the proper format because we always isolate the y. Okay, so the only thing left is get that y by itself. That's what step 3 says. And then we'll be done. Okay, so how would we do that? I think once again the clearing fractions idea is probably your best bet. It would be that same 2 that we used before. If I clear the fractions, I'm going to have 2x. Here the 2's would cancel, so 3y and plus 12. I'm trying to get that y by itself. If I subtract 12 from both sides, and then it looks like divide by 3, I ought to have it. There is a note here in step 3 that says if you have a linear function, which we do, the expectation is that you would go ahead and put it all the way to slope-intercept form. So I should go ahead and distribute that 3 into both parts. and that gives me y equals 2/3 x minus 4, since 12 divided by 3 is 4. The final step in terms of giving your answer is, just now that you're done, go ahead and go back to the function notation. So replace y, this time not with f of x, but with f inverse of x, to remind us that that's what we found, the equation of the inverse function. Here would be the final answer. You'll have the opportunity to practice this a little bit as you're going through the homework. You just want to make sure you get these steps down. One way we could check ourselves is we could look at that last example. Remember earlier when we figured out that f inverse of -6 was -8, we did it kind of this backwards way. Now that we have the actual equation of the inverse function, we can just plug -6 into it and verify that we do in fact get -8. Let's try that. So f inverse of -6, that would just mean replace all the x's here with -6. I think I'm going to write it -6/1 because I can see what's coming. And start in on my canceling. Let's see, I would end up with a 2 here. So 2 times -2 would be -4. Take away 4, sure enough, is -8. It's the same thing we got before. Now we were able to just do it in a very straightforward way because we have the equation of the inverse function. I suppose another way you could check is you could take the original function and you could take the inverse function that we just got, and you could graph both of them in your TI along with that diagonal line y equals x, and you could see if these two looked like they are mirror images of each other across that line. That would be another way that you could confirm it. The main thing is that you learn this process and that you are able to carry it out.